Hello, everybody. I want to start talking about the syntax of C++. Again, remember, I'm assuming that you understand what the algorithmic concepts are about. This first program that's on the screen right now is the same as I did when we had the Zoom session on Monday. What to look for in this, I've written down here. I want you to notice again the # include that brings in packages, functions, what we need, and the using namespace standard, which tells where that package comes from. IOStream is used for input from the screen and output to the screen. And the major workhorses are cin and cout. And you'll notice the chevrons. I always think of this as hello world is going to the outside world. It's going into cout. When we do cin, the chevrons will go the other way. Next thing, again, I remind you the int main gives the program a name and a type. That means that it's going to return a value, and the value is going to be int. The name is main. The parentheses say there are no arguments to this. As with Python, when you put a def in, you were able to put arguments in. We will do the same thing when we get to functions in a few weeks. Let's see. Return 0, returns a value. Most of our programs will have a return 0 in it unless they are a certain kind of function, a void function, which we'll talk about. Open and close braces are very important. They're used everywhere. They basically take a group of statements and turn them into a block. The block is important because variables are defined within the closest block. That is the concept of scope, which we will be talking about during the semester. As I said, the / represents comments. Now, I want to start talking about assignment statements. They are very similar to what we have inside Python. Here is a program that simply takes the height and length of a solid and computes the area. I shouldn't have said solid, I should have said a rectangle, but that's okay. You'll notice that I asked the user to, I tell the user what I want the user to put in. Then I read those items. When I'm reading more than one item, I can have I separate them by the chevrons. I made a mistake. This one is a solid. I'm computing the volume, actually, not the area. Now, the area, I should have called it volume, equals width times height times length. And when I'm outputting, I can mix the quotes, which puts these words on the paper, and I can have a name of a variable, which puts the value from that variable on the paper. Indel says, I am going to have a return at the end of this line. It's very useful, otherwise things scrunch up a lot. In here, it's very important that you understand the difference between Python and C++. C++ cannot use a variable until it's been defined. And the definition tells what kind of variable it is. That's almost opposite to the way Python works. We have defined these variables to be int. That means if I try to put in 3.6, it's not going to work. It's not a decimal. It's an int. Here are some kinds of names. You'll notice that I use the underscore here. That's not a hyphen, it's an underscore. And it's allowed in variable names so that you can separate parts of it, so that you can make them maybe more readable. There can't be any spaces in the name of a variable. That's why we have to have something like this. Now, it's also possible to have numbers. And as I said when we were talking before, uppercase and lowercase are different. We have to be very careful of that. As I said, I've lost a lot of time on that. Let's see. Here are the ones we're going to use right away. Int stands for integer. It's a type where you can only put in whole numbers. You can have like -8, 15, 2007, but you can't have 15.02. Double is for real numbers. That is numbers that we are going to look at as having values past the decimal point. The surprise might be that even 1.0 is a decimal number if we express it that way. It is not saved the same way in the computer as 1 is saved. When we want a double 1, we want it that way, and we have to declare it double. That comes up in division in particular. Char just says we have a variable that is allowed one character in it. That character can be anything that we can print. It can be a special character, a letter, a digit. It is one character, though. And the method, we'll see, we don't use the double quote for it. We use the single quote to have constants of that particular value. String is not much different, I'm sure, than what you're used to from Python, except you can change the values in string. And as with Python, you can access each character in a string. One position in a string holds one character. So strings are just groups of characters. Bool is a special variable, kind of variable. It has not a numeric value, but a truth value. And the constants are the words true and false. Don't get confused with the quotes. I'm just putting them there so I can separate them out. The words themselves are true and false. Actually, inside the computer, these are numbers. But in C++, when we have a Boolean variable, they are treated as true and false. In case you didn't catch this in 103, which is possible because it's not really part of 103, the inside of a computer only stores ones and zeros. Huge strings of ones and zeros. If you wanted to look inside, you'd be unhappy. You'd see all these zeros and ones floating everywhere. The meaning of those zeros and ones is controlled by how we use them. The same place in memory could store a double, an int, a char, a character. We just don't know. It depends on how we interpret it. And C++ is very fussy about this. It will insist that you decide how you're going to interpret it when you're writing the program. Now, assignments are the same. The left-hand side is a variable. We have the equal sign. And the right-hand side I call a well-formed formula. The abbreviation for that is WIF, WFF. There was a game many years ago called Whiffs and Proofs, which used this kind of well-formed formulas. All it means for us is that the formula makes sense, that when we put it together, we can compute it. We can use constants, we can use operators, we can use some special functions, which I'll show you in a minute. The operators are the same as in Python, but we do not have an exponentiation. If we want exponentiation, we want like x to the 7th, we have to use a function called POW, power. And I don't have an example of it here, but we'll have an example of it later. There are 5 operators: addition, subtraction, multiplication, division, and modulus. The modulus only works for integers, and A mod B is the remainder when we divide A by B. So 6 mod 4, 4 goes into 6 once, and we have 2 left over. So 6 mod 4 is 2. The division is a little bit dangerous. You have to be careful of it. If you divide 6 by 4, you do not get 1.5. You'll get 1. That's called integer division. And what it means is if the two sides, if the numerator and the denominator where you're doing the division are both integers, the answer is an integer, and it truncates the answer. I don't care if the answer comes out to 1.999, it is still 1 when we do the integer division. That's actually a good feature. We'll use that in various places. As I said there. Now I'm going to have another problem. I'm going to input the width, height, and length of a solid. Oh, that was the answer from the program. The next problem is going to use doubles. It is to put in a quadratic equation, ax squared plus bx plus c equals 0, and determine what possible values x has. This is a typical high school problem in algebra. I hope you saw it. And it's been known for centuries how to solve this problem. There are 3 possibilities when we're talking about real answers, that's double answers. We have either 1 root, no root, or 2 roots. And this is the way we're going to solve it. We're going to first input the 3 values. Now I can input integers, but they'll be converted into doubles because the variables are double. But that doesn't mean I can't input 3 or 6 or something like that. The discrim is defined in the theory of quadratic equations as b squared minus 4ac. Notice I wrote b squared as b times b because I don't have the exponentiation. Also notice I can't leave out the multiplications. When I say it, I say b squared minus 4ac. But when I write it, it has to be 4 times a times c. If you leave out any of them, you'll get into trouble. Now the next one is jumping the gun a little. It's not really an assignment. It's just I wanted to be able to do something, so I brought in the if statement. You've done if statements. You've done if, else if, else if, else if, else. There really isn't any difference. we use a syntax slightly different. We say if, else if, else. It should always end in an else. A syntactic difference with Python is that the question is put in a parentheses. And every question has one block that it controls. So look at this one right here. This is one statement according to C++. It's a compound statement with several statements in it. But because we have the braces around it, as far as the else if is concerned, it's one statement that it's going to execute. It's very important that we do that. That this can only control one statement. So if we want to have more than one thing that we're going to do in this particular case, we have to have the braces around it. Now, what this statement says in colloquial terms is, if the discriminant is less than 0, then there are no real roots. If the discriminant is greater than 0, then I have to compute the square root of the discriminant. There's no square root symbol, but there is a built-in function called sqrt. And in the parentheses, you put what you want to take the square root of. Now, I fixed it so I'm not taking the square root of a negative number. When we're working with doubles, which are another name for reals in mathematics, we can't take the square root of a negative number. When we do that, we're moving into the field of complex numbers. And we're not really working with complex numbers. They exist in the language, but we don't need them for a long time, at least in this class. So I made sure that I wasn't below 0. This is only going to be done if the discriminant is greater than 0. That's why I did that. Now, in that case, there are two roots. Minus b, you've probably heard of it in high school, is minus b plus or minus the square root of b squared minus 4ac, all things divided by 2a. That's what I have here. But I can't write plus or minus. I have to have them in two separate statements. Also, notice the parentheses. The C++, like Python, has an order of precedence, what it does first. It always does multiplications before it does additions. It also goes from left to right. If we left out this parentheses that I've got highlighted here, we would be dividing by 2 and then multiplying the result by a. So I have to tell the machine, even though you go left to right, do this multiplication before you do the division. The parentheses are used to change the order. The same thing is true of this parentheses. Since I want to do the addition before I do the division, I have to put this in a parentheses which says, go inside there and do that first, then do your division. Otherwise, it wouldn't work. Now, in this third one, there's only one root, because essentially in the real quadratic equation, the square root of 0 is 0. Notice that I can put a well-formed formula in the output if I want to. But up here I wanted to do it differently so you could see it better. But here I thought it was small enough that I could put in there. And then I have my return 0. We do a lot of if, else, whatever. They're a very important part of the language. So get used to this. I could have as many else ifs as I wanted in there. But at the end, I should have an else. Basically, that means everything except the things that I was checking for above. Now, I wrote most of that down in the what to notice in here. In the precedence, I look at it as you go inside the parentheses first, and you do what's inside there. Then, if there's a unary minus, then you have to do that. Now, if you look, there is a unary minus here, negative b. Then, after that, you take care of your square roots, and then, or any other functions, and then you do all the multiplicative kinds of items, and then you do the addition and the multiplication. Now, actually, there are many other unusual operators that will be coming across later in the semester. I think there's something like a list of 32 levels of precedence if you look on the internet. But this is all we need for now. I mentioned the if-else structure. Here are the outputs, some outputs. I tested it for all possible cases. Now, this is a bugaboo of mine. I've seen this over and over. Students write their program and turn it in and don't test it. You've got to test your program with one example of each possible section. In this particular program, I have three possibilities. I can have one root, no root, or two roots. I needed to test all three possibilities. They were separate. They were separate runs, but you'll notice this is x squared plus 1 equals 0, and that's x squared equals negative 1, and there are no real numbers that do that. This is 3x minus 7.5x plus 3. These two it really turns out to be the multiplication of x minus 0.5 times x minus 2. And in this one, if you compute the discriminant, it's b squared minus 4ac. It comes out to be 0. At least it seems to. Now, third program. I don't like this. It's too much. There are too many decimal digits there. I'd like to fix that. To fix it, I have to bring in another package. It's called IOmanip. And what IOmanip is a set of words, functions that tell the output how I want things arranged. It gives me more control of the output. In this particular case, I'm using three parts of it. And it's right here. I'm using fixed, set W, and set precision. Now, what do the three of those say? Fixed says every number is going to have the same number of decimal digits, every real number. Set W says that when I output it, I'm going to have it take 6 spaces, which means if it's like 1.20, that only takes 3 spaces, so I need to put 3 blanks before it when I output it. And the set precision says the number of decimal digits I want is 2. Now, I wrote those there and here, and you'll notice the only difference is the output. If you look at this output, you get 0.50 and 2.00 instead of what we got before, and here you get 0.67. That's compared with the output that was here. And notice it rounded off. It took 0.666 and made it 0.67. So that's a pretty output. That's part of what we do occasionally to make things look good. It's handled through manip, and basically you just have to get used to it. Now, one more. This just explains what I just said. This is integer division and modulus. What I'm talking about now works for integers. It's very important for integers. What I'm going to do is I'm going to do a very simple conversion. I'm going to give you a number of inches as my input, and I'm going to output that number of inches in feet and inches. So if I give you 22 inches, the first 12 inches make 1 foot, and then I have 10 left over, so I have 1 foot and 10 inches. I hope that's understandable to everybody. So again, I ask for number of inches. I input number of inches. Now here's where the algorithm uses the division and the modulus. If I have 22 inches, if I divide by 12, it truncates the answer. It does not give me 12 plus 10 twelfths. 1 plus 10 twelfths. It divides by 12 and gives me the whole number of twelfths that are in inches in. So if I want to get inches out, all I do is divide by 12. Feet out. All I do is divide by 12. So if I put in 13, that would be 13 divided by 12, but because they're both integers, it comes out 1, not 1 point something. So that's where integer division is very useful. It allows me to make conversions like this and use it for other things. We use it a lot. Now, what about the number of leftover inches? Well, when I divide, let's say, 15 by 12, I get 1, and there are 3 left over. 3 inches that are not in the foot pot. Well, that's the remainder. When I divide 15 by 12, the remainder is 3. That's exactly what the modulus does. It gives us the remainder when we divide the A part by the B part, where A is before the modulus and B is after the modulus. So what that does, if I have 15 there, say for inch in, then it's 15 divided by 12 and take the remainder. It's 3. There's minor difficulties when you use negative numbers. It doesn't always seem to work beautifully. But if you stay with the positive numbers like this, it works without much trouble. And remember, it's only for integers. You can't use it for real numbers. If either of the two is double, you can't use modulus. And here's the output. I didn't bother making it pretty. There's the information I just gave you about modulus and integer division. And here's the one of the outputs. And unfortunately, I can't bring it all up. There it is. There's the output. Now what I'm going to do is post this particular file. I think it's already there actually. It's called 104 Notes 1. It's under class notes. I'm also going to post this particular video. If you want details about this, then what I suggest